Swayam Prabha. Digital India. Educated India.
Welcome back. So, we were discussing dominant strategy. Two cases we discussed where each of the players have a dominant strategy and another case where one of them have a dominant strategy, and both the cases unique equilibrium was guaranteed, right, we have shown. Now, suppose can there be a case where no dominant strategy? If there is no dominant strategy, what will happen? There is a beautiful game called Battle of Sexes. Okay. So, that game you will see that there is no dominant strategy and it will have multiple equilibrium. Okay. Say exactly like that. Okay, Battle of Sexes game I am coming. Okay. So, what is the Nash equilibrium? Nash equilibrium, let us define Nash equilibrium. So, in the earlier lecture the two games, and when we told that one unique equilibrium is guaranteed, that is also Nash equilibrium. Okay. Once you know the Nash equilibrium definition, in this light you can judge those two things, you will understand the which we refer as equilibrium, that is Nash equilibrium. Okay. What is Nash equilibrium? Nash equilibrium is basically a pair of strategies in this particular case. Why pair of strategies? That many strategies, how many different players are participating? Here only two players are participating in the game, that is why we are telling a pair of strategies. One strategy for me, another strategy for the other player. Okay. If three players are playing, it is a tuple of strategies, one strategy from each of the players. In that way, that is the Nash equilibrium first. But that strategy, it should, what clause it should satisfy, so that it will be called a Nash equilibrium. Given the strategy of the other, what will be my best? Say suppose say top and bottom kind of thing, right. So, suppose top is the best for me given when I know that column is going to choose left. So, given left, top is the best for one person. If parallelly it will also happen, if this person knows that top is other person's decision, if other person is going to choose top, left will be best for that person. So, it is a pair of, so this is best given this, not only that, this is best given this. Okay. So, we need a pair of strategies, one strategy given that strategy for the other player, which is the best for me, given this strategy for me, that is the best for that other player. So, if that way we get a pair of strategies, that pair of strategies is called Nash equilibrium. Okay. So, it has two clauses. So, top given left, this is for row, and left given top, this is for column. If this is the case, this top means the best one, best, left means here it is best. Okay. So, if this is the case, best strategy is top given the left for other, and best strategy is left given the top for this person. Okay. If that way, then top left will be a Nash equilibrium, top left. Top is a one strategy for one player, left is another strategy from the other player. Okay. So, that way, so both way it should satisfy. Okay. Now, suppose say girl, boy, okay. This is action, art, action, art. This game is called Battle of Sexes. This game is a beautiful game. It is about a would be couple. Okay. And it is a long back this game, context is long ago, right, when there was no phone, no mobile phone and all those things, right. So, in a would be couple, and they decided that tomorrow they will go for a movie together. okay, but they forgot to decide which movie hall they will visit, okay, and to actually two adjacent movie halls are there. One hall some action film is running, another hall some art film is showing, okay. So now when tomorrow movie going time came, right, they are basically indecisive kind of situation, which hall they will go they did not decide, okay. So look at here, if it happens to be the case that the hall where action movie is showing, right, boy is going to that hall and girl is also going to that hall, then so they can enjoy together the movie, right, that was the target, they will watch the movie together wherever they want. But if this cell is generated, what is that? 0 0 means what? Boy is going in one hall where action movie is showing, but girl is going to the art another hall basically, okay. So eventually they land in the two different halls, okay. So they have to watch separately, that is why it is not that much enjoying to them. So that is why 0 0 for both of them, that is the payoff structure. Exactly in this case this is 0 0 and this is 1 2, okay. Look at here, their first target is to watch the movie together. The second thing is this two payoff structure is telling another important information hidden here. Boys usually like more action film and girls usually like more art film. Look at here, their target is to watch the movie together. So togetherness is satisfying when both are going to the action hall or both are going to the art hall, okay. But when both are going to the action hall, look at here, boy is getting 2 and girl is getting 1 as satisfaction, okay. That 1 2 those are the quantified representation of the amount of satisfaction or amount of utility they will extract from watching that movie, no, that way, okay. So alternatively when both are going to the art hall, look at here, boy is getting 1 and girl is getting 2, okay, girl is getting more. So one important information is hidden here, and that boy's natural tendency to go before the or go to watch the action film and girls natural incentive to watch more art film, okay. That is usual way, you as a boy you may be different or another girl may be different, but that is the usual case, okay. That is the thing. More importantly, another hidden information is there. Look at here, although boy wants action more like to watch action movie, in this when this cell is generated, what is happening? Boy is watching action movie only, but girl is watching art movie, right. So both are getting 0 0. So essentially this girl is getting this one, no, this is from accompanying, they want to watch that together, right. So that is why although boy is watching action movie, okay, he is getting 0 here, and girl is also watching art film, she is getting also 0, because they are missing that togetherness, okay. Exactly that way here also they are missing togetherness. Anyway, that is not the issue here. So issue is here whether any equilibrium is here or not, or any Nash equilibrium is here or not. Look at here, first question is whether any of them have any dominant strategy. Look, for boy one case he will get more here because he is comparing between 2 and 0, in another case this is 0 and 1. So one case he is getting more by choosing action hall, another case he is getting more by choosing art hall. Exactly the same way girl, okay, one case, so girl is comparing this pair of number, this 1 and 0 and this 0 and 2. So one case she is getting more here, another case she is getting more here. So none of them have any dominant strategy. So if they do not have any of them have any dominant strategy, then though we have to calculate or we have to more carefully see whether there is any Nash equilibrium or not, right, okay. Because when at least one of them or both of them have dominant strategy, Nash equilibrium is guaranteed, we have shown that, very easy to find out which is the equilibrium, right. In this case, look at here, see if given action for, so suppose this is girl, okay, if boy know that girl is going to go for action movie, what is the best for boy? Definitely boy will choose 2, because this thing girl is going to choose. So boy is going to compare between effectively this 2 and 0, boy will choose action. So, boy best option is action, given that if he knows that girl is going to action. What is the girl's point of view? If girl know that boy is going to going for action movie, then what girl will decide? So, action, boy is going to these things. So, girl will compare between these two numbers 1 and 0, and by 1 girl is getting more than here 0, right. So, given action for boy, action is the best for girl as well. So, this action it is satisfying both the clauses of the Nash equilibrium. So, definitely action is a Nash equilibrium here. Exactly same way, this is also art also another Nash equilibrium here. Why? Okay. If boy knows that girl is going to go for art film, what is the best strategy for boy? Boy will compare, because girl is going to choose this art, no, that time boy will compare between these two numbers 0 and 1. So, by choosing art, boy is getting more, because by choosing action, in that case boy will get 0, by choosing art boy will get 1, right. So, basically art is the best strategy given art from girl. So, this is the best for boy, given knowing that art is going to be the girl's choice. Exactly the same way, if you see from girl's perspective, if girl know that boy is going for art, so then girl will compare between these two numbers 0 and 2, and these two numbers comparison is telling that girl should choose art, because by choosing art she will get 2, alternatively by choosing action she will get 0. Okay. So, here is more. Okay. So, art also is satisfying the clauses of Nash equilibrium, both way matching kind of thing. So, we are discussing on peculiar game where multiple Nash equilibrium is there. Okay. One Nash equilibrium here, another Nash equilibrium here. Okay. So, what we discuss? We discuss that all these games what we are discussing in this course, those are called pure strategy game. Okay. Other than that, there is another kind of game called mixed strategy game, which we are not discussing in this course. Okay. But in advanced game theory you can learn that. Okay. Forget about those things. More specifically we are discussing pure strategy game. So, we get different types of game, okay, where both have a dominant strategy, unique equilibrium is guaranteed. At least one of them have a dominant strategy, again unique equilibrium is guaranteed. When none of them have a dominant strategy, multiple equilibrium is there, 2 equilibrium we are getting. So, natural question can come to your mind or some of your mind that, sir, can there be a situation where there is no equilibrium? Okay. Yes, that can happen. Let us choose one payoff structure. Suppose this is the payoff structure. Okay. Say suppose 1 2 2 1. Okay. Suppose this is left, that is right, this is top and this is bottom. Okay, look at here what is happening. Okay. So, first question is there any dominant strategy for this person? Suppose this is Mr. Row and that is Mrs. Column. Any of them have any dominant strategy? Okay, look at here. If we compare these two number, more for bottom, these two number more for top. So, row does not have any dominant strategy. Exactly the same way, these two numbers more is left, these two numbers more is right. So, none of them have a dominant strategy. Now, the question is whether any of the is there any Nash equilibrium or not. Where there is no dominant strategy, in the battle of sexes we have discussed that it is a multiple Nash equilibrium, right. Here look at here, given left, when this row knows that column is going to choose left, right, that time what row will choose? row will choose bottom, because that time row is comparing between these two numbers 1 and 2. So, row will choose bottom. Now, if column knows that row is going to choose bottom, in that case if column's best thing is left, then bottom left is a Nash equilibrium. Look, when column knows that row is going to choose bottom, what best is column, what is the best for column? It is not left, they are right, because column is comparing between these two numbers 1 and 3, right. So, by choosing right. So, this is suppose column and this is suppose row. So, given columns left, row's best is top, but given rows, no, given left, not top, bottom, given left for column, row's best is bottom, given bottom for row, when this side we are taking, given left, this is the best for row, given bottom for row, right is the best for column. Exactly same way, given right for column, what is the best for row? If row knows that column is going to choose right, it is best for row is 1 and 3. So, top. Now, given top for row, what is the best for column? If column knows that row is going to choose top, column will compare between 1 and 2. So, this is left, left is the best for things. So, we are not getting any pair of strategies, one strategy for row and another strategy is column, which can fulfill both way requirement for the Nash equilibrium, right. So, this is a peculiar game where there is no Nash equilibrium. So, what 4 alternative types of games we have discussed here to introduce here, actually main target to introduce dominant strategy and Nash equilibrium, and in that context we are discussing that if dominant strategy is there or dominant strategies are there, okay, then so one Nash equilibrium is guaranteed. In the absence of any dominant strategy, both the possibilities can happen. Multiple Nash equilibrium can appear, no Nash equilibrium also can appear in this kind of 2 cross 2 simultaneous game. This is 2 cross 2 game, it is called 2 cross 2 game in the sense that 2 players are playing, each of them have 2 strategies, in that way 2 cross 2. Okay. So, in that way so many games in the real life is there, you will see that 2 cross 3 kind of games are there, no, rock paper scissors, I am sure that many of you know that rock paper scissors game, where 2 parties are playing, but each of them have 3 strategies, either rock or paper or scissor. Okay. So, it is a 2 cross 3 kind of game. So many interesting games are there real life. In fact, this kind of look at here no, whether I am choosing left or right or you are choosing top or bottom, that strategically determined, okay, where I will get better, given his choice or her choice, like that, right. So, these kinds of strategic interactions are very important in oligopoly market. So, that is why we are first introducing this game theory to familiarize ourselves. Another important game is called prisoner's dilemma game. Let us introduce that prisoner's dilemma game and then we will go to the oligopoly discussion. Prisoner's dilemma game, it is basically the story about a couple of prisoners. Okay. So, they have been caught with the allegation that they jointly made some crime, okay, that is the allegation, okay, and this is the payoff structure. Okay. So, this is accept. So, this is the thing. So, this side prisoner number 1 and that side suppose prisoner number 2. Okay. So, story is that two persons are caught with an allegation that they jointly made a crime, okay, and they have been put in two different cells in a prison, okay, and tomorrow suppose they will be produced before the court. Okay. So, what is their strategy, and accordingly this is the payoff structure. Okay. So, the thing is that this accept means what? Every prisoner has two options, right? When judge will ask, no, whether you made a crime, right, what he can respond, either yes, we made the crime, or no, we did not make the crime. So, that is why accept and deny, two strategies, and similarly prisoner number 2 also have the same two strategies, right. And the look at the payoff structure. Okay. If and these two prisoners, no, they will be produced before the judge, okay, one by one, okay, not simultaneously, but they have to decide what they will tell. Say prisoner number 1, what he is telling before the judge, no, that will not be prisoner number 2 can't see that, or do not know that, okay, what that person is going to tell judge, right. So, they have to decide, but this payoff structure each of them know. Okay. If he deny, if I accept, what he will get, what I am getting, I will get, in that way everything is known to each of them. Okay. So, that is the thing. So, look at here the payoff structure, its interesting story is involved. When both of them are accepting, what will happen? Then to just is coming to the decision, definitely they jointly made the crime. So, each of them will get -3 as if the -3 basically 3 years of imprisonment. Okay, that minus we are taking -3. Now, look at here, when prisoner number 1 is accepting and prisoner number 2 is denying, that means this cell is generated, right. That means what? Actually they jointly made the crime, but this prisoner number 1, he is an honest person, he is accepting that he made the crime, but this prisoner number 2, he is a liar basically, he made the crime, but he is denying that, he is lying. So, as a result punishment is that kind. So, this prisoner number 1 will be freed, but prisoner number 2 will get more punishment because of his lie. Okay. Exactly the same way here, when prisoner 2 is accepting, prisoner 1 is denying. So, basically prisoner 2 is an honest person, he is telling truth, but prisoner 1 is a liar in this case. So, prisoner 1 is getting more punishment, okay, and he is getting less, and this is -1 like say some technical kind of thing, right. See, when you are caught and put in prison and when you are going to be prosecuted before the judge or before the court, right, there is usually some gap, no, suppose that gap they have to in any case by default serve say few days in the prison, that is why it is -1. When both are denying, I am also denying, other prisoner also denying, perhaps there is some benefit of doubt just will give to both of them. So, this -1 is basically technical thing, right. So, this is the thing, this is the story behind the prisoner's dilemma game. You will realize that in real life oligopoly market, which we will discuss here, no, cartels and how cartel can break and all, cartel we will discuss, cartel we mention. If you can remember, sometimes back we told OPEC, Organization of Petroleum Exporting Countries, why OPEC can't maintain high price for long back we have discussed that OPEC actually a cartel, oil cartel, no, international few 7-8 countries who are actually controlling the 75% or 80% of the entire world petroleum demand. Okay. So, they form a cartel called OPEC. Okay. So, how that cartel usually not maintain high price, right, by voluntarily cutting their production decision, right, that we have discussed sometimes back using the elasticity things. During the short period elasticity is more inelastic, or demand for that petroleum product is more inelastic, but over the longer period it is becoming more elastic. Okay. As a result price is not price will be above, but income from selling that product will come down because elasticity scenario is changing, that we have discussed earlier, right. That is the one side of the story, why in the long run or for the longer period they can't maintain high price. There is another strategic behavior involved into the each players within the cartel, each members of the OPEC, right, and as a result whatever price they will set, that will break. that we will discuss. It is a very interesting game, and this kind of prisoner's dilemma kind of game is involved there. We will discuss maybe the next lecture we will discuss that. Okay, oligopoly market more specifically we will discuss in the next lecture. Today we can complete only the game, all kinds of game discussion, right. So, look at here what will be equilibrium here. Equilibrium here, look at here, it is an unfortunate kind of situation, accept is a dominant strategy for each of the player. Okay. Prisoner 1, from his perspective you look at here, he is comparing between these two numbers, where he is getting more, one case is -6, another case is -3. So, he is getting more by accepting in vis-a-vis in these two cases. If he compare, here is 0, here is -1. Okay. So, it is also by accepting it is he is getting more. Okay. Exactly the same way prisoners 2, see he is comparing between these two numbers and these two numbers, both the cases by accepting he is getting more. So, accept is a dominant strategy for each of them. Prisoners 1's dominant strategy is accepting, prisoners 2's dominant strategy also is accepting. So, accept is a dominant strategy for each of them. So, naturally this will be the Nash equilibrium in that case, okay, and each of them will accept the crime, okay, and they will get 3 years of imprisonment. Although they know that if they each of them deny, okay, they can get less punishment, okay, -1 kind of thing, right. Very well they know. Look, the story we told in prisoner's dilemma game, we told that they have been put in 2 different cells. Okay. That means what? Implication is that before the their production before the court, they can't jointly or they can't negotiate or they can't collude among themselves, that they discuss among themselves and they decide, okay, we will deny it like that. So, that is the purpose of making them into 2 different cells. Now, suppose even if they are putting in the put in the same cell, what will happen? They will discuss among themselves and they will decide that, hey, you will deny, I will also deny, both will deny, so that we will get less punishment. But when each of them will produce separately before the judge in the court, no, each of them will accept. Why? Because we negotiated and I decided that, hey, you tell deny, you will deny when judge will ask, and you also told me that both of us will deny, no. So, I am sure, quite sure that he is going to deny, right. So, he is going to deny when I know, then what I will do? I will surely accept, because when he is going to deny, if I accept, I will get 0, even more reward, -1 vis-a-vis 0. Okay. Exactly the same way, that other person, he knows that I am surely going to deny. So, he will get the incentive to accept, because he can improve his benefit even more from -1 to 0. So, it is basically, although even if they are allowed to negotiate, discuss among themselves, okay, and decide jointly what to do tomorrow, okay, but cheating motive, cheat the other person, okay, that motive will make them to accept before the judge. Okay. So, this cheating motive is very strong in this kind of within any kind of cartel, including OPEC. Okay, that we will discuss. We will discuss in specific oligopoly kind of things, real life situation and all, using some real life example and all we will discuss. So, these kinds of things, and whatever oligopoly discussion is there in our syllabus, okay, mostly concentrating on this prisoner's dilemma kind of game. Then the question is, why I introduce so many other type of games, at least battle of sexes and other kind of thing, or another game where there is no, that will make you interested. Okay, you will be getting more and more interest to learn game theory. There are a lot of interesting games are there in there. Hawk dove game is there, scorpion frog games are there, so many games are there, interesting games are there. Okay, kidnapper hostage kind of game is there. Okay, so kidnapper hostage, basically one kidnapper kidnapped someone, okay, he is the hostage, and now after kidnapping, no, he is in a dilemma whether to kill the hostage or whether to free him. If he free, he will tell, he may tell, he may not tell also, he will tell or disclose the identity of the kidnapper, and if he kill, no, he will get some less satisfaction or some psychological pain that I am killing someone. So, that kind of lot of games are real life very interesting games are there, you can read, you can search in Google, in internet, you can learn, those are interesting very. But whatever the oligopoly discussion we will do in our syllabus, mostly on the basis of this prisoner's dilemma kind of game. Okay. Lot of other games, arm race game was there, no, in 1970s, no, when Cold War time was there, I am sure many of you heard about that. USSR, which we know that Russia, that country, its full name was USSR, Union Soviet of Socialist Republic or something like that, USSR, that is the full name, okay, and United States of America. Okay. There was an arm race between them. Okay. So, each of them want to build more and more arm. What will happen? They will not have that much resource for their developmental activities within the country, right. So, society will lose, but if I bring one of them actually build arm and other concentrate on more social kind of spending, right, social beneficial kind of spending, who is building more arm, he will get more powerful in the strategic market or strategic power market globally. Okay. So, there is a strategic interaction involved there also, what to do given what other party is going to choose and all those things. So, lot of interesting games are there, you can introduce, you can familiarize yourself also, but whatever minimum game theory discussion is required, we have discussed here. Let us stop today, and next lecture we will exclusively or quite exhaustively discuss oligopoly market and what kind of strategic interactions are involved, like this kind of strategic interaction, and how cartel can be broken because of this prisoner's dilemma's cheating motive. Okay. Let us stop here.